So, dear students, uh, हामी चाहिँ नि प्रिभियस भिडियोमा चाहिँ नि पुरा अर्ग्यानिक कम्पाउन्ड्सहरुबाट चाहिँ नि अल्केन कसरी बनायौं हैन त्यो सिक्यौं। अब चाहिँ नि यसमा चाहिँ नि अल्केनबाट अरु अर्ग्यानिक कम्पाउन्ड्सहरु कसरी बनाउने त्यो सिक्छौं है त। त्यसो भए फर्स्ट अफ अल we'll study how to prepare alkenes, right, and alkynes from alkene, right? So suppose you have something like this. Okay, first of all we'll treat this with x2, that is your presence of light. In the presence of light, so what will happen, this will be converted to alkyne. Then we'll do dehydrohalogenation reaction of this, that is with the help of alcoholic KOH. Now this will produce alkene, right? That is your this one alkene, by removal of this halogen and one hydrogen from here, right? So this is what happening from here. This is the preparation of alkene. From here we can again react with x2. This will produce RCH X CH2X, which on further reaction with alcoholic KOH will give alkyne, right? RC triple bond CH, right? Next, how to prepare alkyl halide, right? Alkyl halide. So this is the reaction, right? From here to here, see here, this is alkyl halide preparation, right? Third is how to prepare alcohol from the how to prepare alcohol, right? So let's see here how to prepare alcohol. We prepare first of all this alkyl halide, right? This is your RCH2 CH2X, right? Then what should be done? We should react this with KOH, but this KOH is aqueous KOH, right? Here we used is alcoholic KOH and here it is aqueous KOH, and this will produce RCH2 CH2OH, right? This is your primary alkyl halide. If you use here secondary alkyl halide, that is your R2CH CH2, suppose if you use this one, right? If you use this, okay, if you use secondary alkyl halide, then in this case it will give mixture of alkenes and alcohol, alkene and alcohol. If you use tertiary halide, then this will give with aqueous KOH, okay? With aqueous KOH, this will purely give what? Alkenes. Are you getting it? So you must be clear on this. So fourth is preparation of ether from alkane. So suppose this is, first of all we prepare this one RX, we prepare this alkyl halide, right? We prepare alkyl halide from alkane. Then we react this with what? Ag. We react this with Ag2O, and this will give you what? ROR, right? ROR plus Ag2Ag. Okay. So this is your ether, right? Again, ether can be prepared by reaction of Rx with, you can react Rx with R dash ONA, and this will give you RO R dash, right? RO R dash. So in this way you can prepare ether, right? So now next we'll study how to prepare aldehyde and ketones from the alkane, right? Aldehyde and ketone from the alkane. You must be clear on this, okay? So from here we understood that when we use aqueous KOH, then it gives alcohol, but when we used alcoholic KOH, then it gave alkenes, okay? It introduced double bond by the help of dehydrohallucination reaction. That is called dehydrohallucination reaction, okay? Let's come here now, and we'll study what, how to prepare, what is that is the aldehyde or ketone, right? So first of all, you must understand there is alkane, right? There is alkane from which we can prepare alkene, right? From which we can prepare alkene. Yes, we have seen in the previous slide, right? For example, how to prepare alkene from the alkene. First of all, what did we do? We used alkane and we converted it to alkyne halide. We converted it to alkyl halide. Then we converted it to what? That was your alkene dehydrohallucination reaction. We used alkylic KOH, right? And we converted it to alkene, right? In this way we converted them. For example, let's take CS3, CS2, CS3, then we reacted X2, this was converted to CS3, CS2, CS2X, and when we used alcoholic KOH over here, this gave CS3, CH double bond, CH2, CH2, okay. Now from here we'd like to prepare, from here this is CS3, CH double bond CH2. From here we would like to prepare aldehyde, okay? For this, first of all, we'll react this with ozone in presence of CCl4. So now look, it will be forming. Now you have to break this bond, right? So look here, toward one side there is H, this is 2H, right? There is C, and C is bonded to 2 hydrogen, right? So similarly we can do like this here. Are you getting it? Now let's look at this C. This C is bonded to 1 hydrogen this side, and CH3 this side, right? Same thing we'll do here, bonding to 1 hydrogen and CH3. Now we'll do hydrolysis. Right? So this will be broken down like this, and one side this is H, C, H, HO, HCHO, that is your formaldehyde. The next side it is H, C, double bond O. You can say like this. Okay, let's use H, C double bond O, and this is your CH3. So this is called acetaldehyde, right? Acetaldehyde, and this is your formaldehyde, right? So now we'll prepare ketone now, okay? This is aldehyde. First of all, what did we do? We converted this alkane to alkene, right? To alkene. How? When alkane was first converted to alkyl halide, and then by alcoholic dehydrohalogenation with the help of alcoholic KOH, it converted to alkene, right? Then what did we do? Then we reacted that alkene with ozone to form this ozonide, right? To form this ozonide, right? Then we did acidic hydrolysis, and that produced formaldehyde and acetaldehyde, right? Now we'll be studying how to prepare ketone, right? How to prepare ketone. So let us understand this. Suppose you have CS3, CS2, CS2, CS3, right? First of all, I would like to isomerize this one with the help of AlCl3. This will be changed to branched compound, that is CS3, CH, CS3, CH3, right? Now I'll be converting this. Look, this is alkane, this is also alkane, this is also alkane, right? But they are structurally different, right? So now again we'll be converting this to alkyl halide. Let's say chlorine in the presence of light. So this carbon, this is secondary carbon, this is tertiary carbon, right? This one is the third degree carbon. So this is the most reactive carbon over there. Carbon over there. So this forms CS3, C, and this is Cl react over here. This is CS3, this one is CH3. Okay, now what will we do? Alcoholic KOH will use over here, which causes what? Dehydrohalogenation, right? Dehydrohalogenation, and produce double bond over here between any two. So from the adjacent carbon, hydrogen will be lost, right? So this will be CS2 double bond C, this is CH3, and this is your CH3. Now next will be reacting this with ozone in the presence of CCl4. So what will happen? It will form something like this. Okay, so look here, there is one C and two H. So one H like this, one H like this. In this side, across this double bond, can you see there is two CS3, right? One CS3 over here, another CS3 over here. So this is CS3 and CS3. So what will be the compound forming like this? That is HCHO, right? HCHO, that is your formaldehyde, and CH3, C double bond O, CH3, CH3, C double bond O, CH3, which is your acetone, right? So by this way we prepared ketone, right? So now we'll be learning how to convert the alkane into carboxylic acid. Alkane into carboxylic acid. So up to here you are clear, right? How to prepare aldehyde and ketone, right? Okay. So now we'll try to prepare carboxylic acid. What are we going to prepare now? Carboxylic acid, right? So first of all, remember alkene on reaction with ozone and hydrolysis gave what? Aldehyde or ketone, right? or both, aldehyde or ketone or both, right? But when we react alkyne alkyne with this O3 and then we hydrolyze this will give carboxylic acid. This will give carboxylic acid. Okay, so first of all we need to prepare alkyne for that, and we know first of all, suppose this is CS3, CS2, CS3, then first of all we need to convert this into halogen, that is alkyne halide, that is CS3, CS2, CH2, X, right? Then we have to use alcoholic KOH, right, to dehydrohalogenate it. So this will be converting to CS3, CH double bond, CH2. Then we further react this with halogen to convert this into CS3, CHX, CH2, X, and then what will we do? We will again use alcoholic KOH to convert it into triple bond. So this will be CS3, C triple bond, CS, right? Now when we use ozone and hydrolyze this one, so look here, this bond will break at this side and this will produce CH3 and this is C, right? So C and OOH plus, and this will produce HCOOH. Are you getting it? So this by this way we can prepare carboxylic acid, right? Second way of preparing carboxylic acid is from alkene itself. That is, let's suppose this is CS3, CS3 CS double bond CH2. We can prepare alkene from alkene, right? We have seen till now. So if we use KMNO4, which gives nascent oxygen, this will break this one. This will break this one and produces, that is CS3 COOH plus this side is HCOH, HCOOH. Okay, by this way we can prepare the carboxylic acid. Okay, now let us understand. So up to here we came to know that alkene, when reacted with ozone and hydrolysis was done, that produced either aldehyde or ketone. But when the alkyne was done the same, it produced carboxylic acid, right? And then we saw that when alkene was reacted with KMNO4, which provided nascent oxygen, that converted the alkene into carboxylic acid, right? By breaking the double bond, right? By breaking the double bond. So now what will we do? We'll go for preparing the nitro compounds, right? We'll go for preparing the nitro compounds. That is your, in nitro compounds we'll talk about cyanide, we'll talk about isocyanide, right? We'll talk about nitroalkane, and we'll talk about amines. Okay, we'll talk about amines. So first of all we'll prepare nitro compounds. Okay, 2 nitroalkane. Okay, so first of all you need to understand nitration of, we can do nitration of alkane. We can do nitration of alkane, but toward nitration only higher alkanes alkanes respond. Only higher alkanes respond, not the lower one, not the lower one. Okay. Yet let's say this is RCS2 CH3, which is a higher alkane. When reacted with, this is your fuming. This is your fuming nitric acid, and then this gave RCS2 and CS2 CS2NO2, right? Hexane heptane actually reacts with this one, right? But vapor phase, if this one reacted with HNO3, in which phase? Vapor phase, right? All the alkanes, smaller and larger alkane, both gets nitrated in. Both gets nitrated in. Okay, but you need to understand, methane gets nitrated slowly. Okay, slowly. Okay, any problem? So up to here we are done. That when we do nitration of the alkanes with the help of fuming nitric acid, then the nitration of higher alkanes only occur, like hexane and heptane. But if the if the nitration is done by the vapor phase of SNO3, if they are used in vapor phase, right, and they are passed in the reactor tube, then all the alkanes, hydrocarbons, they get nitrated. They get nitrated, right? So now we'll be trying to study how to convert into amine. How to convert into amine. First of all, we know that this is RCH2 CS2 CS3 when got reacted with HNO3, when nitration was done, this was converted to RCH2 CH2 NO2, and when it is reduced with the help of SnSCl, this gets converted to RCH2 CH2 NH2. Okay. Second, when we know that this is RCH2 CH3 is a alkene. When we react this with KCN, this will form RCH2 CH2 CN, right? And when we use LiAlS4, when we reduce this one LiAlS4, then this will be converted to RCH2 CH2 NH2. Okay. Third reaction is, suppose we have RCH2, okay, actually one step is missing over here. We have to convert this compound to Rx first, then we use this one, and then this is converted. Okay, CS3, first of all we have to convert this to Rx. This will be converted to CS2 CS3, there will be X, and if we use, this is AgCN. Remember, when you use KCN, then it is cyanide is produced. When you use AgCN, alcoholic, right, this will be isocyanide. This will be RCH2 CH2NC, that is isocyanide, right? Now you have to do acidic hydrolysis. When you do acidic hydrolysis of this will produce RCH2 CS2 NH2 plus HCOOH. Okay, so this is how we convert into nitro compounds. Okay, like amine, we convert this. How we converted this to the amine. So now, how to convert them into cyanide? So cyanide, here it is. How to convert into cyanide? How to convert into isocyanide up to here, right? So I'll discuss it a bit. Okay. Okay. So now, remember, if this is your alkane CS3, CS2, CS3, and you need to convert this into cyanide. First of all, what to do? You have to convert this into haloalkane, right? And then what did we do? Alcoholic, sorry. From here, we can convert this into cyanide by reacting with KCN, that is your CS3, CS2, CS2, CN, right? If you have to convert into isocyanide from here, you have to use AgCN right here. So this will be converted to CS3, CS2, CS2, and C, right? So upon using LiAlS4 over here, this will be converted to amine, right? Amine, right? Upon hydrolysis, upon what? Hydrolysis of this one, which hydrolysis? Acidic hydrolysis you have to do to convert this into amine plus what? Formic acid. We have already discussed this one, right? So we are done studying this, how to convert. So let us revise once. Let us revise once. So let's come to our revision session. Okay. So the point is, one number, we converted alkane to alkene and alkyne. Process was, first of all, we had alkane, then we converted it to haloalkane, right? Then we did dehydrohalogenation reaction. This converted to the alkene. After doing dehydrohalogenation, this converts to alkene. Then after that, we again reacted with X2, and then again we did dehydrohalogenation, that converted it to the alkyne. Next was alkyl halide. Look here, this is converting to the alkyl halide. Then to the alcohol, how did we do? We actually made up to this one, yes, haloalkane. Alkane was converted to haloalkane, and this was reacted with aqueous KOH, right? Then we converted that to the ether by reacting haloalkane with what? Either Ag2O, right? Ag from Ag2O. Okay. For how did we convert into the aldehyde and ketones. While converting aldehyde and ketone, we did something like we converted to alkene. We converted alkene to alkene, and then we did ozonolysis followed by hydrolysis. Hydrolysis, we did hydrolysis, right? Then uh, what did we do? We prepare carboxylic acid. We prepare carboxylic acid, carbo. We used alkyne, and we did ozonolysis and hydrolysis, right? Then we use alkene here also, and KMNO4 to break the bond. Then we converted into nitro compounds. How did we convert? By reacting with HNO3, right? And alkane. HNO3 plus alkane was reacted. 7. How did we convert to amines? By reducing nitroalkane. There was nitroalkane and it was reduced by SN plus HCl, right? Then we converted we converted into cyanide, right? We converted into cyanide, and then we used LiAlH4. You can also use NaC2S5OH, which is your Mendes reagent. We converted the haloalkane into isocyanide, right? And then what did we do? We did acidic hydrolysis of this one to convert into amines, right? How did we convert into cyanide and isocyanide? Cyanide and isocyanide. Are you understanding? Cyanide was converted by the use of KCN to haloalkane, and isocyanide was prepared by reaction of AgCN to haloalkane, right? So we are done up to here. In next session we'll try to convert the alkane into aromatic compounds, right? Aromatic compounds. Thank you.